Good morning.
Good morning.
Good morning.
So how's everyone today?
Pretty good.
All right, that's good to hear. All right, so let's see. Is Avery there in Joseph City?
Yeah, he's here.
Okay. How about in Holbrook? We missing anybody?
Everyone's here.
Okay. All right, good deal. All right, so let's just kind of go through the week here. So today we are going to, I'll answer any questions that you have as far as for review. And then we're going to go on to 3.5 and maybe 3.6, depending on how much time we have. Tomorrow we are going to do the midterm part 1. And then on Thursday we're doing the midterm part 2. Okay? So after today, there will be no broadcast until next Monday. Okay. So really, Friday's the last day that you have to make up stuff. Okay. So if you, because I'm going to be, we'll be finalizing the midterm on Monday morning. So if you need to make up anything, let me know. Okay. And you can't do like, well, I'm not going to mention any names, but you can't email me at 9 o'clock at night and want me to open something up at 8 in the morning. Okay. I don't do office hours at night, and I actually have intentionally do not send my work email to my personal phone, just because I don't want to. All right. So, you got to do it during business hours, so to speak. Okay, and you also need to make sure you talk to your talent aide. And I know at 9 o'clock at night you're not talking to your talent aide anyway. But that having been said, I know you're kind of, some of you might be kind of slammed to get some stuff done. And so I'm going to try to support you all I can. All right, but I just want you to know my limitations as well. All right. So any questions about the calendar or what our schedule is for this week? All right. So then the next thing I want to know is, does anyone have a question on anything that they would like to go over from 1.1 through 3.3?
So I don't have a specific problem in mind, but would you be able to go over a problem where you have to find the GCF and so multiplying and dividing complex fractions?
Wait, are you talking about, you want problems where we're factoring or multiplying?
Multiplying.
Multiplying. Okay. So that's in chapter 1.
Wait, actually adding or subtracting, not multiplying. Sorry. So
Okay. See, here's the deal. I don't mind doing problems all hour long, but I would like to do a problem that you have tried. So if you haven't tried one, then I kind of don't want to do one, because I want you to try it and see if you can do it, and then see how far you can get, and then you'll learn twice as much. Okay. So maybe you can like be working on one while somebody else has a question. Okay. So does anyone have a problem that they've attempted that they would like me to help them through? Yeah.
I have one. It's
Please.
on the chapter 1 test, and it's
Okay.
number 20.
Chapter 1 test, number 20. Okay. All right, let's just do this. Okay, number 20. All right, so it says to solve 5 times, oh, here, I don't think I switched the camera. Okay, there we go. So 5 times 3y minus 2 equals 4y plus 4 plus 2y. Okay, so if we're going to try to solve this, it's not a quadratic or anything, and so this is just a linear. So the idea is we want to get all the constants on one side and the variables on one side, the constants on the other. So the first thing we want to do is simplify both sides of the equation. So here what we want to do is distribute the 5 to get rid of the parentheses. Oops. So that would be 15y minus 10. All right, over here we can just drop the parentheses, and that's no problem, and combine the like terms. 4y plus 2y is 6y. Okay, and now we get the y's together on one side by subtracting 6y. And then we get the constants together by adding 10. And then finally, to get y by itself, divide each side by 9. And so we get y equals 14 ninths. Okay, and you could do that as a decimal, but the fraction gives you the exact answer. Okay, now one of the things that I would do is after I worked through the whole test or the whole midterm, what I would do is check all the answers. Okay, and so in this one, but frankly, I wouldn't do it until you finished. Okay, because sometimes the check can take longer than doing the original problem. And so here to check this, you're going to plug in 14 ninths in for y. So what I would do when I'm checking an equation, I would definitely use the calculator here. So let's come on. Wake up. All right, so let's clear that. So using the calculator to check an equation, if you take your answer, so 14 ninths, and then store that in for x, okay, or you could use y, it doesn't matter. And then what you do is you type in both sides of the equation and see if you get the same thing. So 5 times parentheses 3y, well, I'm going to use x now because I stored it in for x. So 3x minus 2, close parentheses, and then I press enter. And it doesn't matter what you get there. What matters is that when you type in the other side, you get the same thing. Okay? So then, dang it. All right. So now I'm going to type in the right side. So 4x plus 4 plus 2x Okay? And so it checks. So you got the same thing on both sides. Okay? All right. So is that okay, Seth?
Yeah.
Okay, great.
Can I have you do number 36 on the chapter 1 test?
Sure.
Thank you.
$36?
Yeah.
Okay. So here we have a complex fraction. So we want to simplify. So 1 divided by 2a minus 1 divided by 2b, all divided by 2 over a plus 2 over b. Okay, so you can't have a complex fraction like this as part of your final answer. So what you do to clear a complex fraction, you look at all your little denominators and you multiply numerator and denominator by the least common denominator of your little denominators. Okay? So you look at 2a, 2b, a, and b. And so what would be the least common denominator there?
Is it 2AB?
2ab. So you're going to multiply both numerator and denominator by 2ab. Okay? Now, so when you actually, how I'm going to write it, I'm going to actually write it with each term. Instead of multiplying the whole thing, I'm going to write it with each term because stuff's going to cancel easier and you'll be able to see that if I've got that with each term. Okay? So every term, everything, in both the top and the bottom are going to be multiplied by the least common denominator, 2ab. Okay? So, let's see here. All right. So now what's going to happen is that the 2's cancel here and the a cancels here. So all I have left from this first term is just b. Minus. Okay, now here the 2's cancel, the b's cancel, and so all I have left from the second term is minus a. Okay, now here the a's cancel, so then I have left 2b times 2, so that's 4b. And then here the b's cancel, and so I have left 2 times 2a, so that's 4a. Now, you'd think you'd be done, except this 4 you can actually cancel out. I mean, not cancel out, factor out.
Should it be a plus on the bottom?
Oh, thank you. Well, that'll change everything. Okay? That changes everything because now we could factor out a 4, but it's not going to cancel. I guess in my mind I was a little excited about canceling that, but it's not going to cancel. So that means that's the answer right there. Okay? All right.
Can you do number 92 on the chapter 1 review? It's not
Sure.
a test.
92, chapter 1 review. All right, so 92. So we have y over y minus 1 plus 1 over y minus 4 equals y squared over y squared minus 5y plus 4. Ooh, okay. So I just saw a shortcut. Okay. Which is really kind of nice for this. Anybody see a shortcut? That's kind of, I don't know, that's kind of an unfair question. Here's the thing that I was looking for, is that usually when you have an equation with fractions, to clear out the fractions, you multiply everything by the least common denominator, okay? So let's just do that. Let's just forget about shortcuts. Let's just do it that way, okay? So I'm going to determine the least common denominator here. All right, so we have a y minus 1, a y minus 4, and then this right here factors to y minus 1 times y minus 4, which is pretty dang convenient. Okay, so that is going to be the least common denominator. So I'm going to clear everything, multiply everything by that. Okay, so I'm going to multiply here by y minus 1, y minus 4, and then the other side of the equation by y minus 1, y minus 4. And so I'm going to just write it with each term, because I'm going to multiply every term by y minus 1, y minus 4. Okay, so now what happens? Well, here the y minus 1's cancel, so I'm just left with y times y minus 4 plus. All right, here the y minus 4's cancel. And so then you're left with 1 times y minus 1, which is just y minus 1. And here, the y minus 1, y minus 4 cancels with that entire denominator, leaving you with just y squared. All right, you got it from there, or you want me to keep going?
Keep going.
Keep going. Okay, so now I recognize this as a quadratic. So with a quadratic equation, you want to have it set equal to 0. Okay, so I'm going to move everything over here to the right. So we have y squared. Okay, so, oh, wait a second. I forgot to simplify that first. Let's simplify the left first. So if we have y squared minus 4y plus y minus 1 equals y squared. Okay, now the y squareds are going to cancel. So that's nice. So then it just becomes a linear equation. So negative 4y plus y is negative 3y equals 1. So y equals negative 1/3. Okay? So if it was a quadratic, see, we put everything on one side and set it equal to 0. But if it's linear, then you do the constants on one side and the variables on the other side and solve. Okay? So y equals negative 1/3. All right? And so then, again, you'd go through, mainly on these, the thing that you have to be careful with is that you don't get a 0 in the denominator. So like if we solved and got y equals 1, you'd throw it away. If you got y equals 4, you'd throw it away. Same 1 and 4 over there too. Because that would give you a 0 in the denominator and you can't have that. So otherwise it should check. All right. So Avery, do you want me to go through and do the check on the calculator, or you think you got that?
I think I got that. My main issue was I didn't know when to move it across the equal sign and put a 0 on the other side.
Oh yeah. So you do that when it's a quadratic, but you see, like down here, I actually almost made a mistake. Well, I mean, I would have figured it out, but I started doing it too quickly. You want to distribute and simplify, and then because the y squareds cancel, then you don't set everything equal to 0. Okay. All right, but that's an easy mistake to make and to fix, so it's okay. All right. Anything else?
Can you do number 24 and 25 on the chapter 1 test?
All right, I can do one of them at a time, if that's all right. It's hard to get it to do both hands at the same time. I mean, I could probably do that, but smart board. So let's start with 24 on this chapter test. Is that all right? Okay. Okay. So we're doing 24. Okay. So solve the following inequalities. Describe the solution set using interval notation and by graphing. Oop. All right, so we have -8 is less than 3x minus 5 is less than or equal to 16. Okay? So, and this is a compound inequality. And so what we want to do is get the x by itself in the middle. So here we're going to add 5 to each part. So we get -3 is less than 3x is less than or equal to 21. And now divide each part by 3. And so then that gives us -1 is less than x is less than or equal to 7. And remember, I don't reverse the inequality just because I got a -1 for an answer here. The only time you reverse the inequality is when you multiply or divide by a negative. Here I divided by 3, so no problem. All right, so that's the answer written as an inequality. So then it says to write it at an interval notation. So that would be parenthesis, -1, comma, 7, bracket. Use a bracket to include the 7. So that's the inequality, the interval, and then the graph would be a parenthesis here at -1, a bracket here at 7, and then shade in between.
So, Mr. Strong,
Yes.
so the inequality signs, you have to do the same thing on both sides or, between each one. That you treat in the same aspect as the equal sign?
Yes. Yep.
Got it, thanks.
We put it back on there.
Yeah, it's a little different than an equality because you have three parts. But whatever you do to one part, you do to all three parts. Okay. All right. Any other questions on this one before we go to 25? Okay. So 25. All right, we have, so same idea. So negative 3 times x minus 1 is less than 12. And x minus 4 is less than or equal to 9. Now, the last one where it was scrunched together, it was actually an and as well. This is an and, but it's not written together. So we're going to kind of solve each of these separately. So here I distribute the negative. Well, actually, instead of distributing the negative 3, what I'm going to do here is divide both sides by negative 3. Okay, and so then I'll get x minus 1 is greater than negative 4. Okay, because 12 divided by negative 3 is negative 4. And when I divide by negative, I have to flip the inequality. So maybe I'll write that in. So I'm dividing both sides by negative 3. So then just finishing this off, I get x is greater than, so if I'm adding 1 to each side, so negative 4 plus 1 would be negative 3. So x is greater than negative 3. All right. Okay. Okay. So now with this red one, I'm going to solve this, I'm going to add 4 to each side. So I get x is less than or equal to 13. Okay, so now to graph this, I'm going to graph it next. Remember, it's an and here. So I'll graph the red one first. So it doesn't matter which one you graph first. So we're going to have a bracket on 13 and shade to the left. Okay. Then we have x is greater than negative 3. So I have a parenthesis at negative 3 and shade to the right. Okay. Now, in the middle I have an and. So that means my final answer is what was shaded in red and green. So both times. So I need to clean it up. So my final answer is just what's shaded both times. So that would be from negative 3 in the parentheses to 13 in the bracket, and then I'd shade in between. So that's the part that was shaded both times. So that's the answer as a graph, and the answer as an interval would be parenthesis -3, comma 13 bracket.
Oh, I don't like those at all.
Can you do 31 on the chapter 1 test?
Sure. You don't like those at all? I'll make sure there's at least 3 of them just for you. Okay?
Okay.
All right. Just kidding.
That's sad.
I would do that to you. All right, 31, you said, Lauren?
Yeah.
So,
All right, so here I've got solve the following equations. 4x to the 18/7 minus 2x to the 11/7 minus 3x to the 4/7 equals 0. Okay, so, all right, this definitely looks diabolical. All right, so what you've got to think about are just the basic steps to solving. But I'll tell you, Lauren, my initial thought was to just punt and use the calculator. Okay? But let me just show you the math teacher way. Okay? So here we're going to factor out the GCF. So 4, 2, 3, there's nothing to factor out. But there is an x and everything. And so then you factor out an x to the lowest power, which would be 4/7. And then you write in parentheses what you would have left. So that would be 4x to the, okay, so you subtract 18/7 minus 4/7 is 14/7. Oh, that's actually kind of nice. Minus 2x to the 11/7 minus 4/7 is 7/7, which is nicer still. Minus 3, and then all the x's went away. And so now when we clean this up, we have x to the 4/7 times 4x squared minus 2x minus 3. So to solve this, you set this factor equal to 0. X to the 4/7 equals 0. And if you raise both sides to the 7/4 power, you're going to get x equals 0. So you're going to get x equals 0 from this. From this in here, I would use the quadratic formula. You think you got it from there, or you want me to keep going? Anybody? I mean, it doesn't have to.
I have a question.
Okay, fire away.
So when you factored out the x to the 4/7 power, why are the x's still inside there? I'm confused.
Well, okay. If I have 5x to the 3rd minus 10x squared, okay? Let's see, plus 15x. Okay? So what would be the GCF of that?
Five x.
5x. Okay, so if you factor out a 5x, what would you have left? What would you have left in this first term?
that one.
Say it again.
X squared.
X squared minus
2x
2x
plus 3.
plus 3. Okay? So you factored out an x. Why are there still x's in there? I mean, that was exactly your question. Why are there still x's in there?
I don't know.
Because you're factoring out the greatest common factor. So when you factor out a greatest common factor, you write down in parentheses what's left. Sometimes you'll have x's left. Sometimes you don't. It just depends on what's left.
So Mr. Strong,
Yeah.
so could you like put it in expanded form and then cancel out or
Sure.
whatever? Yeah.
Sure. So then, I mean, it's a little harder when you have fractional exponents. But for something like this, see, you could write this as 5 times x times x times x minus 2 times 5 times x plus 3 times 5 times x. And then you say, well, what do you have in common in all of those? Well, there's a 5 in each term. So you put that out front. And so you have a 5 here, here, and here. Oh, and back that up. Sorry, circle the wrong thing. And here. And then you also have an x in each term. So x here, here, and here. So that's your GCF. So then when you write in parentheses what you have left, see, you still have x's left. So then you got to write those in. So if you have them left after you factor out the GCF, you're still going to have x's in your answer. So back up here, okay, the GCF is the power of x to the lowest exponent, which was 4/7. And so then, it's kind of hard to expand this out when you have a fractional exponent. So when you factor, you subtract, okay? Because see, when you have x to the third and you factor out x to the first, 3 minus 1 is 2. You have 2 x's left, okay? So here, when you factor out x to the 4/7, you've got to subtract to figure out what your exponent, what you have left after you factor out the GCF. So 18/7 minus 4/7 is 14/7. 11/7 minus 4/7 is 7/7. And then here, 4/7 minus 4/7, they all factored out. Okay? Does that help?
Yeah, a lot. Thank you.
Okay. You're welcome. And keep asking questions.
Can you finish that problem though?
What?
Can you finish that problem though?
Okay, sure. So I would use the quadratic formula on this. So let's say A is 4, B is -2, C is -3. So then x equals, what the heck just happened? Okay. That was weird. Okay, x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So that gives me 2 plus or minus the square root of 4. And then I have -16 times -3 is 48 over 8. Okay? Now at this point, I would look at the answers and see, are the answers decimals? In which case, I would just put it in the calculator. Or if they're in radical form, then I would continue simplifying the radical. All right? So let's see. What number was this? Oh, the 31. Okay, so they have the answer as radicals. So, wait, that's an equal there. Okay, so that would be x equals 2 plus or minus the square root of 52 over 8. And so the square root of 52, then I come over here and say, okay, square root of 52 so that's, let's see, 4 times 14, 13. So that's going to simplify to 2 radical 13. All right, so then that's going to, and I'm going to go ahead and separate that. So 2 eighths plus or minus 2 radical 13 eighths. And so that's going to be 1/4 plus or minus radical 13 fourths. So I get those two answers, and then also x equals 0. I'm going to bring that down. So I actually have 3 answers. Wait, what just happened again? Okay, so that's my third answer. So I've got 3 answers here. Okay. All right. Any questions on that? I'll tell you right now, that's probably a little harder than I would give you as a question on this.
Mr. Strong?
Yes.
Can you do question 35 on the chapter test?
Question 35.
Yeah.
Chapter 1.
Okay, now my hope is that you've actually been trying these problems. Okay? Because if you're just looking and saying, oh, that looks like a hard one, let's have Mr. Strong do it, it's not going to be as effective as a review for you. Okay? I'm just telling you that right now. But here, what we want to do is think of the rules for fractions. If we have a fraction divided by another fraction, then we're going to want to change it to multiplying the reciprocal. Okay? But now what I'm going to do, though, along the way is factor everything. Now, this is really going to test our factoring abilities here, so that's good. So this first one, we can factor out of 2, and then we have 2x squared minus 15x minus 8. And I might be able to factor that some more, but I'm going to just keep going here. The next one I can factor out an x, and I have 2x squared minus 19x plus 24. And I might can factor that out some more. Times. All right. So I'm going to factor out the denominator and write it in the numerator. So I can factor out an x. And I have 2x minus 3. And then this I can factor out a 2. And I'm left with 2x squared minus 17x plus 8. So far I've got x's to cancel, and I've got, so these x's will cancel and these 2's will cancel. Okay? But I might can factor some more. All right? So, okay, so now I'm going to, so the math teacher in me says, okay, so now you factor, and then cancel common factors. Okay? But the student in me says, okay, there's one little trick here that we might try, is to see if 2x minus 3, well, let me just back up. See, all three of these have a number in front, and so I would use the AC method typically for all of them. Okay, but that takes time. And so, what I'm going to do is I'm going to kind of cheat a little bit and see if 2x minus 3 can't be a factor of this, because negative 3 is not a factor of 8. But it might be a factor of 24. So if I had 2x minus 3 as a factor of this, then the other factor would have to be x minus 8. To get negative 8 times negative 3 is 24. So what I need to do is check the middle term, and so I'll get negative 3x minus 16x is negative 19x. And so that's it. So what that means is I got the 2x minus 3's to cancel. Okay? All right, so now the next trick.
Mr. Strong, sorry,
Yes.
but could you go over how you factor 2x squared minus 19x plus 24 into x minus 8? Like how you turned the x minus...
Okay. What I did, I didn't do it the way I taught you.
Yeah.
Okay? Because the way I taught you was the AC method. I didn't do that because what I'm trying to do is see if I can cancel that factor. So what I did is I wrote that down, 2x minus 3, and then I figured out, okay, what times 2x would give me 2x squared? 8. What times negative 3 would give me 24, negative 8. And so then I checked the middle terms to see if they work, and they did.
But how did they work? How do you know?
Okay, remember FOIL?
Oh, I
So
see.
the outer and inner product have to add up to negative 19.
Okay.
So that's what I want.
Okay, got it. Thanks.
Okay. All right. So let's try it again. See, I've got the 2x minus 3's to cancel. Now I want to see if x minus 8 cancels. And negative 8 could be a factor of negative 8. So I'm going to try it again up here. So x minus 8. Okay. So then the factors of 2x squared would be x and 2x. The factors of negative 8 would be negative 8 and plus 1. So now let's check the middle terms again. So I'm checking the outer and the inner product to see if I get negative 15x. So that's negative 16x plus 1x is negative 15x. So that's it again. So that means I got the x minus 8's to cancel. So what am I going to do next? I'm going to check to see if 2x plus 1 could be a factor of that. Okay? So I'm going to write 2x plus 1. And what would the other factor have to be? Oh, actually, that can't work. Because the signs have to both be negative. Unless I wrote the problem down wrong. Yeah, I mean, I could have 1 and 8, but their signs would have to both be negative to get a negative in the middle. Okay, so that means it's not gonna factor there. That's not gonna work. So now I just write down what I have left. And so the final answer is gonna be 2x plus 1 is what I have left on top. And then on the bottom, everything went here, and so just that trinomial, 2x squared minus 17x plus 8. So basically, you just write down what you have left. Okay? And you really don't need parentheses. They're at the top. All right, well, we're about out of time. And we didn't get to any new material, and that's perfectly fine. But what I would recommend to you is that you continue practicing work. I don't want you to test with each other, but when you're studying, you can certainly study with each other. And then if you do the book test and the book review, then you can check all your answers in the back and see how you're doing, okay? And see what you need help with. I would highly recommend that before you go through the midterm. So tomorrow, the midterm part 1, and then on Thursday, the midterm part 2. And then you're going to send me an email if you need anything opened up. Okay? Questions before we call it? All right. Well, good luck, everyone. And I'll see you next Monday.
Thanks, Mr. Shaw.
You bet.